Okay, welcome everyone to this continuation of what is machine learning in mathematics and not the other way around. So really how machine learning helps to advance mathematics. And today I would like to talk about a certain paper which I summarized under the slogan of formula guessing. It will be this paper I'm going to talk about, and I stole a lot of pictures from there, and they call whatever type of AI, very kind of baby AI, we'll see. They call it the Ramanujan machine. Essentially, like Ramanujan was discovering formulas, and this machine should discover formulas. That's essentially what it is. And why I like it so much, because it's automatically generating conjectures. In this case, on formulas. And we'll see what that means. So we go a little bit through that paper. So formulas have been around in mathematics for a long time, and for some reasons people really like nice looking formulas. Yeah, so whatever, e to the I pi equals -1 or something. Some nice formulas. And you might wonder how difficult it is actually to get formulas. So essentially what I would like you to have in mind is that whatever is doable in mathematics right now, in 2025, when I'm recording this video, potentially not when you watch this video, whatever, what is doable right now with machine learning should be fairly simple. So with AI should be fairly simple. So how difficult is it actually to be Ramanujan? How difficult is it to be, to kind of discover formulas? Okay, so let's say something like 2 over pi or something. Copy a few digits. Let's see whether AI can actually guess what that is. Okay, so I have the number with more digits, and I wonder whether it is some known number. Let's see. Famous constant. Don't directly match. Yeah, it's not pi. I can tell that it's not pi. And then it tries, that was really pathetic. Let me know if you can get ChatGPT to kind of tell me what pi over 2 is. So not just an approximation of pi over 2. But it actually should be a fairly straightforward. If you do something live, it doesn't work, right? So it should be fairly straightforward to actually do that. And we'll do something similar, a little bit more sophisticated. And again, as I said again, we might wonder, how difficult is this actually, right? You'll see actually the idea in this paper is like brilliantly simple. It's like brilliant and simple, and it's remarkable that it works so well. It's kind of also remarkable that nobody has done it before, but it's also remarkable that it works so well. So I'm a big fan of simple ideas. I don't like long proofs. Simple ideas are much better. So they focus on a certain type of equation, certain type of formula, which is fine, namely continued fractions. Here probably the most famous continued fraction ever. The golden ratio is 1 plus 1 over, 1 plus 1 over, 1 plus 1 over, and so on and so on. Maybe also like a continued fraction expression. We all know that pi is 22 over 7. In case you haven't known that, pi is really just a fraction. It's 22 over 7. And really kind of continued fractions, they have been around for a long time. And people like them a lot. Everything has a continued fraction expression, like pi here. I only wrote the first part of it. I just truncated it, yeah. So and then just 22 over 7, and yeah. So people love them a lot. There are many of them, and they can approximate numbers, and they sometimes are just ridiculously, remarkably simple, like this formula here. So it's really good. So that's what it's all about. So essentially, you want to guess. Want to construct continued fractions expression for various numbers, and you can just think of these numbers as forming a sequence. So essentially whatever, A0 is the first one, A1 is the next one, and then these numbers form a sequence. So B1, B0, maybe B1, and so on. And essentially you just want to find A0, A1 up to the up, and B1, B0, B1 up to the up, and then some nice expression. And then you want to go and try to prove it, right? So this is an idea kind of based in this automated conjecturing, which is different from proving, right? So if you want to just be very brute force and say mathematics is just conjecturing and proving, theorem proving, then this is the conjecturing part. So that's what we're up for. Yeah, so continuous fractions, everyone really, really loves them. And there are various expressions of continuous fractions. For example, here 12 over 5 has two different expressions. So how can we find such formulas? And also how can we find efficient formulas, like to converge very fast, or give us good approximations, like 22 over 7 is actually a pretty good approximation to pi. So how do we do that? Huh? So that's our problem. We focus on a certain type of, well, formula, just continuous fractions. Why not? Because everyone likes continuous fractions. And the algorithms this paper, or the idea this paper here proposes, is like, it's like really, really easy, like really, really simple. And it's so easy that I'm shocked that it, first of all, works very well. And second, that nobody has tried that before. So it's a brilliant idea. Essentially, you generate a list of, well, you just choose your sequences here, the A's and the B's. Oops, the A's and the B's, the A's and the B's. You just choose them and generate a list of potential values. And you take your favorite constant, whatever E, and generate a few expressions of it and get a list of potential values. And you match them and just try to see whether you find something that matches. So here in my little expression, S is 2.7 and S is 2.7, and you just match them appropriately, and then you just have found the formula, or at least a conjecture for a formula for, well, in this case, E. Yeah? 2.71 is something like E. And here's a funny continuous fraction expression of E. I've never seen that one before. And they call this a Ramanujan machine. And I make the point here again, this is a ridiculously simple algorithm. Yeah? It's a very simple thing to do. You can barely call that AI, right? It's essentially nothing. But, and then again, we don't really know how the brain works. So you might argue that certain easier tasks that the brain can do actually work like that. It's kind of a very, very simple type of algorithm. Well, then can just, it's essentially the idea that just a lot of numerical data a computer can generate this just easily and just match them and just hopefully something comes out. And it can do this automatically, right? You don't need any human input at all. It can just do it automatically, and it will find various formulas. So I can just show you a list of some of those formulas, and as soon as you have the formula, so mathematics, as I just said, you can just brute force say it's conjecturing and theorem proving, but it's really not half-half, or at least I don't think it's really half-half. So conjecturing is a huge part of it. And as soon as you have a conjecture, it's often not very difficult to just prove it. And that actually happened here. So in the very end, they have this, some of the appendix on the various formulas they have proven. So new formula, and it is proven, right? So here, whatever, we can zoom in a little bit more. Let's see whether we find something that this looks reasonably nice. So 1 plus E over minus 1 plus E is 2, 6, 10, 14 for the first one, and 1, 1, 1, 1. It's actually a pretty nice formula, and I wonder whether this is really new. And then they discuss how fast it converges as well. So I'm very surprised now, actually, that this formula was not known. 2, 6, 10, 14, 1, 1, 1, 1, 1. Okay. And then they have way more formulas. Whatever, E over E minus 2, 4, 5, 6, 7, 1, 2, 3, 4. This formula was also not known. Yeah. Anyway, so remember from the slide I showed you, they essentially stick together many versions of, well, my favorite constant, let's say E, and then some polynomial shift or something of it, and at the same time they generate a lot of things on the other side, and then they just match. It's kind of a very easy thing. And they have a lot of very impressive formulas. Here's pi, 4 over pi. Oh, this one was known. This is boring. It was known. Pi divided by 4 minus pi, 4, 7, 10, 13, 2, 9. Not so great. 1 plus pi over 2. No, that's pi over 2. 3, 6, 9, 12. Okay. 2, 9, 20, 35. Pretty simple formulas, as you can see. 4 over pi. No, this one apparently was known. Conjectures of pi, and you can scroll down. Other constants. Pi squared. Pi squared is not pi. Fair enough. You could call that another constant if you want. But anyway, 8 over pi squared, God knows. And then convergence is, yeah, whatever. And then it's remarkable what they have discovered. Like a lot of these formulas. Yeah? And what is even better is that they made everything open source. So people ran it themselves and discovered even more formulas. That's how mathematics nowadays should work, right? You make your work accessible and then just let other people take over, because that's how we function as a society. That's how we function as human beings. You alone, or me alone at least, I can't do much, but as a collective, we're actually pretty good, or pretty bad, depends a bit how you want to say it. But in this case, proving type of funny continued fraction, or no, not proving, conjecturing those continued fraction expressions turned out to be really, really powerful and really, really good. Yeah, the only complaint people had is people complained about the name, because Ramanujan's formulas are just way more impressive than this little. I mean, this is a cool formula: e divided by e minus 2. I mean, 1, 1, 2, 3, 4, 5, 6, 7, 8, and so on. And we can just anyway, but it's the original Ramanujan formulas were just way better. Yeah, they're just much more impressive. But let's be realistic. The algorithm they use itself, it is a bit more sophisticated than what I actually showed in this video, but it's pretty simple AI. Yeah, any transformer nowadays should be very much more sophisticated. Please, someone double check whether ChatGPT can actually guess what 2 over pi is. I mean, if you just give it the digits, then it should be able to guess that this is 2 over pi. But anyway, so essentially this is a pretty cool thing, because if nice formulas, in this case just continued fractions, baby case, but the super simple algorithm gives continued fractions, this is somewhat indicating that mathematical formulas are probably pretty easy, and some very easy thing in the brain should be able to just piece them together. So what you would definitely want to try next, and I'm pretty sure people are trying this, is to use some more sophisticated AI to get better type Ramanujan type formulas. Yeah? Say it again. Ramanujan's formulas are a bit more impressive than. This one is actually good, but anyway, they're more impressive than these kind of formulas. So we still need to improve the AI. But again, the comparison is here. The brain is in development for, I have actually no idea. Someone tell me, like 1 million years? I have no idea. For a long time, and AI essentially came up in the 1950s. So it's a little bit of an unfair comparison, if you want. Anyway, I hope you enjoyed this video, and I also hope to see you next time.